Ready?
Yeah, it's streaming. Let's see what happens. Play. Is it correct?
Conflict of interest here. Okay, welcome everybody. Today we have 16th class. Today is the last class of this module. After this module, basically, the people who take the part in a test will be split into those people who passed and those people who didn't. People who did pass, we will be doing, obviously, we're going forward with more advanced course, and you're very welcome to join. People who did not pass, we encourage to retry with the more basic course. The reason being, it's not because we don't like you to be there, it's simply you will struggle to understand the material covered. It's nothing against anyone personally. Some people need more time. Simple as that.
What's the passing grade?
That's the question to this chap.
When I've finished it and collected them, I'll let you know.
1 out of 10. 2 out of 10.
Yeah, get one question, I'll say you're done.
Yes. So yes. So the new course will start early in September, and we'll obviously. So if you know other people who want to start and they were afraid because we are quite far ahead in a thing, let them know. They start signing up, and we'll be obviously trying to start this early in September. Another thing is it looks like our second idea, which is to split the class where we have the exercises, that we will try to take exercises out of this class as such, because we realize that because of that the pace of the class is extremely slow. It takes approximately an hour almost to do exercises, and because of that the material which we can cover is basically much smaller. So what we're trying to do, we spoke with the Skills Matters of this place, and they are happy to give us a space in the main area. Sometimes that will be even a room where you can join in and do the exercises from the class. So, for example, a couple of people can join together, use one of the tables, sit down and work on the exercises. We don't promise only me or somebody will be there, but the more experienced people will try to make the effort to be there as well. So in case you have some problems, there is somebody to point you. Yes, one way or another. But we think that will basically benefit the group in a positive way, that we can move on faster, cover more material, and give you a better chance to basically improve your C++ knowledge. Again, we are collecting money, yes, on GoFundMe for Tristan laptop. So if there are any people who want to, contribute to that cause, which I believe is a great cause, Tristan is using his laptop pretty much to write the slides and lead the class from there. So you're very encouraged to do so. Costs like that normally costs 500, 600 pounds. Tristan is doing this basically for free. So if you think it's a good idea, please do help. Anything else? Obviously, after the test is completed and so on, you're very welcome to join us, whether you want to, drown your sorrow or be happy and drink a couple of beers. We're going to beer shank. And I'm giving you Tristan,
What?
as the name.
Yeah, so Tristan's currently stuck on a train, so I'm filling in for this, which cuts down on my time to clean up a few things on the test, but we'll sort it out, it'll be fine. Right, so the obligatory slide 2 that we pretty much always have, right, is we love to hear from you. I wish there was a way I could do this and not have to sort of stand in the way. I might do a quick bit of reorganisation here. That's good, because I can actually use the laptop. Please don't screw this up. Behave. Right. So yeah, as usual, we'd like to hear from you, and please get on the Slack, it's free. You just go here, give it your email, you get invited, and then that's us. Don't forget the uni at the end. Without the uni, you just go to the main channel for the big group, which Jerry here, you had your first experience of that yesterday, right?
John.
Oh, John, sorry.
Sorry. Jerry. Yeah. Sounds like
Because
Right.
I'm Tom.
Yeah, no, it was.
That's probably what I was
Tom and Jerry.
Oh, okay. Yeah. I would say it was very interesting, although it was
But it's
way
quite,
above my.
Yeah, as for
It's
most of you,
pretty-
I
it's
would
very
expect
pretty
that.
pictures.
but it's quite confusing, you know, like you get there and I'm on the stage. You get here, I'm on the stage.
2 days in a row.
You weren't the confusing bit, Tom.
I'm
It
glad.
was the word template smashed all over every presentation.
Yeah. Oh yeah, absolutely. Anyway, so of course we are using this textbook, so hopefully you've got your copy. And yeah, so we're covering everything we've done in the past 15 weeks, followed by my not so short assessment. I did not say it would be a short assessment. You've been lied to. Okay, so the core parts of the revision obviously are covering types, references and pointers. You know, actually, let's just start again. So types in C++, who feels confident about these at the moment? Or who doesn't feel confident? Put your hand up. Okay, no idea back there. Is this your first time here?
Yeah.
Okay, so you're going to be fresh on all of it. Well, we're covering everything from the beginning, so see how it goes. Yeah. References and pointers. Who's
That gets difficult very quickly.
well, we're not going to go too deep into like multi-level pointers, so it should be okay. Variable declarations. Anyone? No, I think you're okay with that. These function declarations and definitions. Feeling okay? All right. Structs. The member functions. These are all kind of groups. So how do you guys feel about this particular chunk?
That was the most challenging one.
Yeah. Yeah, I figured. Okay. All right, so on to types. C++ is a statically typed language, or strongly typed language, or strictly typed language, depending on how you want to call it. But the essential principle is that every expression variable has a fixed type, and the compiler knows what that is. You can't go turning database handles into strings and crazy stuff that you could do in PHP. That makes no sense at all. When we declare a variable, or a return type on a function, of course, or parameters to a function, we have to tell the compiler what type that thing is going to be, or must be. And the type safety rules, of course, allow us to prevent us from passing the wrong thing. If I expect a string and I accidentally, swap the order of the arguments by mistake and you try to give it an int instead, it will fail to compile, and I'll look at it and go, oh, argument's the wrong order. Why does that blank? Okay, I didn't make these slides, don't blame me. There's lots of types, of course, which are built into the language. We call these the fundamental types. So the most commonly used ones are, of course, int, which is typically, but not contractually, 32 bits, but you can pretty much expect most compilers to give you a 32-bit value for those. Bool, which is obviously just true or false, 2 states. A char, which effectively holds a single ASCII character. I take slight umbrage with it saying ASCII. You can effectively put unprintable values in there.
I have a question.
Yes, go for it.
How do you pronounce char? Car.
Char. Char, I don't, it's not a car. You drive a car, that's a char, it's got an H in it. A float, so 32-bit typically, again, doesn't have to be, but it's a floating point number, so floating point means it's got decimals like 1.259, 7.3654. A double, which is just a more accurate floating point number. So with floats, if I declare like 5.7279543, eventually it's got to round it off. And the same applies to a double, but it can express more before it has to round it off. And void, which is actually the absence of any value. You can't actually have a variable that's void. You can't pass a parameter that's void. Void is the absence of something. You can return void, because that just means I don't return anything. But void represents the absence of something.
It's not a null.
I mean, it's somewhat akin to null in some languages. It's not the macro null, but that comes from C. That's just a macro for 0. It's typically used with pointers, but if you're doing C++, you should avoid using null. You use null pointer.
So string is not a type?
Yeah, string is a type. It's not a fundamental type. It's a class type. It's in the standard library, so it's one that someone's written. The library implementer is written effectively. but it's not a fundamental type though. Mainly because you have to include a header. I can write some code without including anything at all, an int, double float, or void. Those all just work, right? I don't have to include any. If I want to use string, I have to include string because it's a library. So an array is a list of values of the same type, which are laid out sequentially in memory, so they're all next to each other. C++ has a built-in notation of array types, which we got from C, essentially. Oh, that went weird for a second. And we have much better alternatives, which are safer to use. The problem with arrays is that usually you pass them around, say as an argument, and commonly they will decay to a pointer, the C arrays, as we call them. And when they decay to a pointer, you can go out of bounds on them. I mean, you can go out of bounds on them anyway. In fact, you could, if it's got 5 elements, you could try and access the 10th element, and you'll probably just crash. So std vector instead is a growable array. So another key point is that C arrays are fixed in size. You say it's got 5 elements, and that's it. It's got 5 elements. Done. Whereas std vector, you can grow it, you can shrink it, all at runtime, and it's type safe. It has to know what type you want to stick in it, and it's basically like acts just like an array. You can use it just like one. Std array, on the other hand, is now taking the concept of saying at compile time I know the size. So whereas this one you don't need to know, you don't need to have a strict size. You can make it bigger and smaller at runtime. This one is fixed, but it is also type safe. And I believe, I'd have to check now, but I believe that the operator square brackets on array throws an exception if you try to go out of bounds, but I could be wrong on that.
Why would you use, sorry, why would you use std array rather than just std array?
Mainly because it minimises the number of mistakes you'll make on the type. So you can do all the same things you would do with a C array, but it will minimise mistakes. I'm pretty sure that if you try to go out of bounds on a std array, it will throw an error.
No, why use it rather than just use vector? Because it's strong.
Oh, I see. So vector allocates your objects on the heap because it doesn't know at compile time how much storage you need. This knows at compile time how much storage you need, and in terms of once it's compiled, what it will be equally as efficient as a C array.
Okay.
And a std string, which is kind of a funny thing to think of as being an array, but it is. I mean, it's just each element in the string is a char. So you can use it essentially the same way. You could of course sort of massage a vector of char to behave like a string in the same way. But obviously this is designed for string-based operations. But if I want to find the word hello inside a string, this has the feature for it. You could do it with vector of char, but it would just be a bit more annoying. So std string is convenient. So reference types. This thing that you just get for free on every type you make. So it obviously is an alias or refers to another variable. I won't put too much then. We can think of a reference as being a sort of, well, a new name. It's an alias. It's an alias, right? Makes sense? Want to use the word alias? Yeah. And you declare it by writing an ampersand after the actual type that you're declaring. So if we declare, int and I, then we're saying that I will be a reference to an int. And a reference cannot refer to nothing. You cannot compile if you just have, say, int and I, because you didn't say what it refers to. So you could say int and I equals some other int, and that's fine. But you cannot ever refer to nothing. And yeah, as it says, they have to be initialized, essentially. And you can't rebind them. So once I've declared the reference and it's referring to something, which it has to do when it's declared, that's it. That's always referring to that thing. If I try to set it to some new value, it will affect the one it was referring to. Pointers. So a pointer is, again, a variable. And instead of being, unlike a reference, it's now holding a memory address that something lives at. So we declare it with a star or an asterisk after the type name again. So int star, and that means I'm pointing to some integer. So I hold a memory address, and if you dereference me, that action goes down into the memory to get the object or set the object that I'm pointing to. and you can now take the address of a standard type. This could be var could be a reference, or it could be a value type. It doesn't matter. But you put and in front of an already declared variable to get the address of that variable. So yeah.
I watched a YouTube video by the Yorn guy. He gave a talk, and he was saying not use pointers, but use smart pointers.
Yes. So it depends. It depends what you're doing. If for some reason you need a variable that could be reseated, that means that at one moment it might point to an object over here, and then maybe later you need it to point to an object over there and give that to somebody else. As long as it's not owning the object, so it doesn't actually own the object in the same way that a reference doesn't own the object, that's fine. Because you just want to be able to point to different things. You don't own them. You don't have to clean them up. You'll just say, yeah, I want to look at this for now, and then I'll look at this later. Smart pointers, he's specifically referring to ownership. It's when you're saying that in the old days you would have like a pointer to some type, and that pointer would represent the owner of the object. So you would allocate it with new to get the memory off the heap. But then because that pointer is owning it, you have to call delete, or you'll just leak the memory when you're done with the variable. When you use smart pointers, they wrap that all up for you. So now you have a lifetime of your smart pointer. When you create your smart pointer, it calls new for you, and when your smart pointer falls out of scope, when you have no use for it anymore, the destructor of that smart pointer is called, and in the destructor, it will delete for you. So now you've got memory safety. So that's referring to ownership.
When you talk about pointer here, you're talking about shared pointers? Is that?
No. These are what we call raw pointers.
Raw pointers.
They're a built-in type. So all the smart pointers are again part of the standard library. They are a library feature. They are not part of the core language itself. Whereas raw pointers are completely part of the language. I can do a pointer to int. I don't need to hash include anything. If I want to use smart pointers, I have to include memory. There's a file called memory. It's in the standard library. Once you pull that in, then you can use smart pointers. So we can dereference a pointer to obtain a reference to the variable by writing star in front of the name. So obviously where this could get confusing, and a way that you can deconfuse yourself, as it were, is obviously when I'm declaring a reference, I also use and. And when I'm declaring a pointer, I also use star. So when you look at any given line involving either of these two symbols, is it a declaration, or is it actually acting on something that's already been declared and created? So if I have int star x, right? I'm declaring something, therefore the star relates to the type. It's a pointer to an int. Once I've done that though, on the next line, I then do star x equals 5. Well, okay, is this declaring x? No, we're not declaring x because there's no type. X was already declared, so I must be dereferencing it. And the same applies to and. If I do, int and x equals b, and then on the next line we do and x, do int star y equals and x. Well, x is already declared, but we're using and on that already declared variable. We're getting the address of it. So we're getting the address of it so we can stick it in a pointer.
So dereferencing gets the value of what it's pointing to. So like when you're doing a pointer type, you're just, for example, pointing to the type in the memory address. When you dereference it, so then what do you get back? You get the...
Dereferencing a pointer returns a reference to the thing. So imagine it as like going a layer down. So I have the int, and then if I get a pointer to that int, I've got to level up, so I'm now pointing at the object. So when I dereference, I go back down. So dereferencing is going down and getting the object, and maybe you want to change it or just read it or write it, yeah? So dereferencing is for reading and writing. When you take the address of, you then go a layer up. So this and var is going a level upwards. So you've started at var being the object, and now you want to go a level up and get a pointer to it. Clear enough? Hopefully? Yeah, okay. And we can also use the arrow operator. This is actually an operator in its own right, to look through a type, or effectively it's a combination of dereference and then calling something on it. So if you have, this is generally useful when you have a pointer to a type. Look who's just arrived. Debatable. So obviously you can use the arrow operator to look for a pointer, and you can access the member functions, member variables of a struct or a class. Yeah, that's where it's most useful. So as an example, if for some reason I had a pointer to a string, if it was I wanted to find a substring, I have to use arrow and then find. So I'd use var arrow, this arrow, and then find to call the find method or the find function in string. If it wasn't a pointer, you could just do dot find.
Sorry, maybe I'm missing something. Why is it important to figure out the memory address of another variable?
Well, it's
The
not.
first line.
First line.
Why is that valuable to know the memory address of another variable?
It's not valuable to know the memory address. It's more valuable to access it via a memory address, because if my object stores just stores a memory address, right? It can be looking at something over here, right? So I don't care about the actual value of the memory address itself, but now that means that, say I want to now point to something else, I just make that pointer point to the new thing. So the old thing still exists, and the new thing's just existing. I can just point to different things.
I think it avoids copying things all over the place. If you have a large amount of data, doesn't it? You can just use the point to
Yeah.
the
So
memory address to point to a set of data, rather than having to move the data around.
So is it that I want to manipulate that other variable, or is it that I want to know what that other variable represents?
I mean, that largely depends on what you're trying to do. So if I had a list of numbers, I could have a pointer to that list, right? And I can make that pointer point to each one in turn, and as I go through them, pointing to each one, I'll add them up, right? So I can have a pointer to some list and then just add, and that's where it's useful. Otherwise, I don't want to be taking copies of all the stuff in the list to add them up. So that's where it could be useful.
If I could say something. So my understanding is that, so when it says memory address, picture like a box, and then that box is a particular type. So if you have like an int pointer, then what it does is it sets a box that's the size of an int that is an int type of box. You can only put an int in there. And then it has a pointer to that box. The box is the memory address.
Yeah.
So you can have the pointer point to some other memory address, or you can dereference it and say dereferencing is just basically saying what's inside the box.
Yeah.
Does that make sense?
Yeah.
So it is finding the value.
Hmm?
So it is finding the value. So like dereferencing is finding the value of what is pointed to.
So it doesn't take a copy though. When you dereference, the result of dereferencing is in fact a reference to the object.
That made me more confused.
It's just saying what's in the box.
So when you dereference it, you just say that I want to look at the thing. I'm not copying the thing, but the result of star pointer, right, is a reference to the underlying object. So it means that if I do star pointer equals 5, because the result of this is a reference, it changes the object that we're pointing to.
Okay.
Yeah.
So, I guess to answer your question, in most cases, the fact that it's a memory address is not the important thing. That's a note for like what it actually is, how it's implemented. If you're doing like really low-level stuff, you're writing device drivers, yes, you care that it's a memory address. But for most of the time, if you're using pointers, you don't really care. But what a pointer does is it sort of acts like a reference, except it's a reference that you can change so it points to something else instead. So you can have a pointer that points to variable I, and then you can change this pointer so that it points to variable j instead. And that's not something that you can do with references.
Yeah.
The cost of that is that you have to do this explicit dereferencing with the star or the arrow, and that we also have this problem with null pointer that doesn't come up with references.
Yeah. So null pointer is a special language keyword. It's built into C++, and it obviously just means the zero address effectively. The reason this was specifically created is because null, the C macro that was brought up earlier, is just literally 0. And of course in C++ we have overloads. So imagine I have two functions, right? One of them takes a point, they have the same name, one of them takes a pointer one of them takes an int. If I use the C macro null, that's actually just 0. So which one's it going to call? We're going to call the int one. If I use null pointer, this lovely one, well, the compiler now knows I want to call the pointer overload with a null pointer. And it won't accidentally or unintentionally end up calling the other overload. So declaring a variable, as we've kind of already seen in the previous stuff, you write the type, a name for it, and then ideally some kind of initializer. And there's about 3 ways. So this is a fairly simple one. Type, it's an int. I'm calling it I, and it's going to be equal to 0. Again, type int j, and this time this is sort of treating it as if it was a class in many ways. If you imagine this was a class type, you'd call its constructor in this way. In this case, we're initializing it to 1. It's the same as equals 1. This is the new modern C++ brace initialization. The reason for this is that I'm trying to think of a good example for why this can go bad. I don't think that can't go bad in and of itself. But there's cases where you can confuse the compiler and make it think you're declaring a function instead of actually trying to initialize a variable. And using this brace is always never going to be that, because I can't declare a function by using curly braces, because the arguments to a function are always parentheses. So I prefer this brace type. But again, it just sets it to 2. And fundamental types, they are all the same. Yeah, that's a very key point, unfortunately.
That's not, I wrote that sentence, fundamental type, all 3 forms are equivalent. That's not, there is a little caveat to that, is that the 3rd form actually protects you from what are called narrowing conversions. So, if we were trying to initialize k with a value that was too big, the 1st and 2nd forms would just truncate it, the 3rd form would actually refuse to compile. So.
But I've seen code where you can initialize with just int I semicolon or int j semicolon.
Yes. That's declaring and not initializing.
Yes, that's an uninitialized variable that is generally frowned upon.
Yeah. So if you create a variable,
I just pretended it didn't exist.
Okay.
If you create a variable uninitialized, then you cannot legally read from it. Doing so, it will compile, but you have no idea what you're going to read. Anything can happen. Your program is invalid. If you need to write to it later, and again, this is pointless these days, because if you don't know what you're going to put in something yet, don't declare it. Declare it when you've got the stuff ready to put in it, right? But previously, years ago, in the days of C, you had to declare all of your variables at the top of a function. We've moved past that now, so just declare it when you're going to actually put something in it.
Just 1 second. The thing about narrowing, that point you made, do you mean like if you, for example, like declare something as a float and then put like or it's the opposite way around, if you put like an integer, you declare an integer and then you put a float or something like that. Is that what you meant?
Yes, precisely that. Yeah. If you do int I curly braces and inside you put like 3.4, the compiler will say no, I can't do that.
Okay, so okay.
Whereas if you do int I equals 3.4, the compiler won't complain, but your int will just be equal to 3.
What about really big numbers then?
The same thing, yeah.
If it won't fit, you get out. So the auto keyword, lovely, very convenient, makes the compiler figure out stuff for us. So, for example, it's going to be an int. It knows because this is an int. Now it's going to be a double. Yeah, it's double by default. You need the F if you want a float. And now we've actually done an operation. So we've added an int to a double. Well, double's there. The result's going to be a double still. So this is going to be a double.
So I still an int?
I hasn't changed.
We haven't set.
Once we've declared it, you can't change the type.
Yeah. The type. When you use auto, it figures out what the thing is at that point, and then that's set in stone. So if this is figured out to be a double, then you can't. It cannot change. You can't stick a string in it. You can only stick doubles in it.
So do you no longer use default constructors then? Because if you're initializing it to 3 there, then you wouldn't need a default constructor, would you?
Well, these are all primitive fundamental types, so they don't effectively have what you would call a default constructor. For user-defined types like a struct, although there's still more complex rules around this depending on what that user-defined type consists of. Some of them will you don't need to strictly initialize. So for example, I can declare a std string, right? And I don't need to do std string x equals anything, just std string x, and strictly speaking that's fine. It will be initialized, it will call the string's default constructor. It will just be an empty string and it's in a valid state. I can ask it for its size and it just says I'm empty.
Yeah.
But that doesn't apply universally. So for certain types, and what were the rules around it? I think if you have a user-defined type like a struct, and it's just an aggregate. Aggregates don't get initialized, do they?
Yeah, aggregates.
These are all these are all fairly complex rules. Until you know exactly what they mean, it's better to just initialize everything.
So had I said auto D and an empty set of curly braces, the compiler would say no, I can't deduce what type B is from just an empty pair of curly braces. I don't know what you're trying to do. If I said, like, imagine there's a fourth line, auto S equals standard string, empty braces,
Yep.
it would say, okay, I've deduced S to be a default constructed string.
Yep.
And that style, you can do that to, you basically use the keyword also everywhere, all the time, and people call it the almost always auto style, which is, it's a stylistic thing, it's not required. Some people claim it has advantages, other people claim it makes your code very unclear. You don't explicitly write types everywhere, but some people prefer using auto for pretty much every variable declaration.
But when you use auto, I guess what I'm asking is, then you do not create a default constructor function, then you just don't even create it.
No, you still need a default constructor. All this is doing is figuring out what a type is. It has nothing to do with the languages, with what you need to actually execute or happen.
The default constructor is created or not created when you write the type definition. This is about creating an instance of the type.
So it's like this is just saying I can't be bothered to write std string s. I want you to, so I can do auto whatever equals std string, curly braces, or I can say here's an existing std string, auto x is a copy of this std string. But in terms of constructors and what needs to execute, this is just to save you a bit of typing. What you need to happen, it still remains the same.
I think that's rarely used. They are important for simple types, but if you've got a long declaration using templates or something, it saves a lot of time.
Massively. So yeah, for such as vector iterator, that kind of thing, or any kind of iterator. So yeah, it tells the compiler to deduce the type for us. It saves us a lot of typing. That's all. And you can also use it as the return type of a function, sort of. It depends on what version of C++ you're on. If you're on C++ 11, you can use it, but all it does is it means you have to put the type at the end of the function. There's a way of doing auto as the return type in C++ 11, and then you do your parameters, and then you do a little arrow, and then you have to specify the return type. In newer versions of C++ since I think 14, and even then under certain cases, you can sometimes not have to put the return type, and it can figure it out from what you're returning. But not always. Yeah, not for function arguments. Except lambdas. Lambdas is fine. But we haven't covered lambdas, so don't worry. Const variables. Actually, you know what? I might swap with you now. So we're about halfway. Yeah, we're halfway. It's a good time to swap. All right, we're going to stop the stream.
No, I'll just carry on from your laptop.
Well, no, because I need to use my laptop.
Okay. Well, then we'll swap it.
Yeah, so for those watching on YouTube, we're going to briefly stop the stream while we do a handover, and then we shall resume. I'm currently on const variables, so we will be back in a few minutes.
Yeah, but I don't really know how to use this keyboard. It's not like I'm using the GPU.
You are using the GPU.
Is that back on, Tom?
No, stop.
Yeah, we're back on.
Oh yeah, obviously.
All right. Quick substitution. So thank you, Ollie, for stepping in. Where have you got to? Const.
Tristan.
Yes.
Sorry, 1 second.
Oh.